We'll be starting this lecture. This is the second lecture of that we are undertaking for this course. In this lecture, we'll be discussing certain more things related to the kinematics and statics of the structures, and the static indeterminacy and the kinematic indeterminacy of the structures. Now, we'll first discuss more examples on beams. If this is visible, now there is a beam here and it has got a support at one end. The support is a hinge support. Then you have a fixed support at the other end. You also have one more roller support here. Then you have another hinge here. So overall, it has got 4 supports. Let there be another internal hinge at this location. Now, how do we resolve this for static indeterminacy? We already know the formula from the previous lecture. Let me recall that formula. Just a minute. Let me write down that formula again. It's alpha into m. M is the number of members, plus then you had R, the number of reactions, minus J into the beta into J plus R or gamma. So for this question, now alpha will be equal to how many forces will there be in this beam? It will be 3. You have 3 shear force, axial and moments. Then beta would be here, it would be again what is beta? It's the equilibrium equation. It will be 3. Then members would be, there are 4 members here. There are 4 members here. This is 1, this is 2, this is 3, this is 4. So you have 4 members. So you have 4 members. Then R is the number of reactions. Now the number of reactions are yes, you have 1, 2, 3, 4, 5, 6, 7, and then you have 1 rotation like this. So total you have 8 reactions, and J is the number of joints. They are 1, 2, 3, 4, 5. 5 joints you have. Gamma, the value of gamma is
1.
You have 2 minus. There are two elements connecting at the red spot at the internal hinge, minus 1. So you have one release. So total, the value of SI would be then equal to alpha is 3 into m is 4 plus r is 8, and then you have minus, now beta is 3, number of joints are 5, gamma is 1. So this total would be 12 plus 8 is 20, 20 minus 16, 20 minus 16 is 4. So you have 4 is the static indeterminacy of this frame. So next we have let's take an example of a truss. We did one of the trusses in the last lecture. Let's take another example of a truss. For example, this is a truss. So if this is the truss, and let there be two supports, 1 and 2. Now both are hinge supports, and all the joints are pinned. Then your static indeterminacy again has the same formula. Now this is your static indeterminacy now. Then, so what will be the value of alpha?
1.
That's 1, because there is only one axial force. They're acting as
Yes,
axial.
sir.
The members are 1, 2, 3, 4, 5.
9. 9.
Reactions you have 4 reactions here.
Yes, sir.
There are 4 reactions. 1, 2, 3, and 4. You have 4 reactions. So this is 4. Then beta value,
2.
number of equilibrium equations that you have here are 2 in truss, if it's a 2D truss. J value, what will be the J value?
3, 4, 5, 6.
6.
Yes, sir. 6.
And finally gamma, there is no value of gamma, no releases.
No.
So the value of SI here now is alpha into beta. Alpha is 1, so it's 1 into M members are 9 plus R is 4 minus, you have beta is 2, J is 6, then you have gamma 0. So overall it becomes 9 plus 4 is 13, 13 minus 12 is 1. So the value here is 1 of this static indeterminacy. Now if you have the same frame acting as 3D truss, the same truss acting as 3D truss. Earlier it was 2D. Now if this is 3D, in a 3D truss, the only thing that varies is the value of alpha would be same. It would be number of axial reactions, that's 1. But
Yes, sir.
beta value,
Beta.
number of equilibrium equations now in a 3D truss are not 2,
6.
they are 3. You have summation of 1 you have of fx equal to 0, Then you have summation of Fy equal to 0. Then you have summation of Fz equal to 0. Not of M. There is no movement. But in 3D, you have three directions. You have three directions in which you have one is this direction, other is this direction, and third one would be this direction. So you have Fx, Fy, and Fz. So there are three um, equilibrium equations in a 3D truss. Now, so what would be the value of SI here? The value of SI would be uh, alpha is 1, then you have members is same 9, plus you again have reactions are 4, then you have the value of beta. Beta is now 3, not 2, and joints are 6, and there is no release. So total now you have 9 plus 4, 13, 13 minus 18. So it's minus 5. So now this is unstable truss. In a 3D, if it's a 3D one, it becomes unstable here. So this is the second example in the trusses that I am giving you. So it's unstable. And then let's move to the frame. Now let's take an example of frame. For example, this is a 2D frame. One of the supports is fixed. Rest of the two supports, let this one be a roller support, and this is a hinge support. The middle one is the fixed support. Again, you will use the same formula to determine static indeterminacy. You use the same formula. This is a general formula that you are using in every to determine the static indeterminacy. So now here, what is the value of alpha first? What is alpha?
3. 3.
Alpha is the axial shear force as well as bending moment. So it's 3. So you have 3 axial shear force and bending moment in a frame. Number of members here are, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are 10 members. The number of reactions for this frame are at this location you have 1, 2.
6.
Third one is the movement here, and this is 1, 2. There is one more, which is the movement here. So in total you have 6. You have 6 reactions. Then beta is the number of equilibrium equations. They will be 3. Summation fx, fy equal to 0, and third one mxy equal to 0. Then J. J is the number of joints. You have 9 joints here.
9.
9 joints. Then gamma is 0. So the value of SI would be equal to alpha is 3, So number of members 10, R is 6 minus beta, beta is 3 into J is 9, then you have plus, gamma is 0. So overall the value is 36 minus 27, that's 9. So the static indeterminacy, overall static indeterminacy here is 9. What about the internal indeterminacy? Internal indeterminacy.
External R minus 3. External.
What you do, uh, the
And
indeterminacy
external.
occurs by, in a frame, occurs by these closed loops. So this is one closed loop, this is another closed loop. So this is closed loop number 1, this is closed loop number 2, this is not closed, and this is not closed, this is not closed, this is not closed. So there are two closed loops. For each closed loop, the indeterminacy, if it was not closed, it would be determinate. As soon as it becomes closed, there are three additional unknowns here. So for each closed loop, you have three unknowns. Now if there are two closed loops, so it will be 2 into number of loops. 2 into 3, it's 6. उल्टा लिखा 2 into 3 times, it's number of loops into 3. 3 is for each single, so you have 2 into 3, 6. So the internal indeterminacy depends upon the number of loops, which leads to internally it becoming indeterminate. So external indeterminacy then would be static indeterminacy, total indeterminacy minus
Minus
internal
internal.
indeterminacy. So it's 9 minus 6. So that's 3. So the external indeterminacy then is 3. There is another way to determine external indeterminacy. Here.
R minus 3.
So you total number of reactions.
Yes, sir.
Total number of reactions minus 3, which is the minimum number of reactions that you would have. So total number of reactions was 6. There were 6. 2 at one hinge, fix पे 3 और hinge पे 1. So this was also equal to 3. So there are two methods to determine. So either you determine the external indeterminacy first, then you can simply determine internal indeterminacy. By this method you can do the reverse thing. आप internal indeterminacy पहले निकाल दो इस मेथड से, फिर external indeterminacy from this last one, तो इन दोनों को ऐड करके you will get the static indeterminacy. So there are various methods of doing this. So next what we have is, let's take another frame. For example, this is our frame. It's a hinge here, hinge here, hinge, or a roller here, or a roller here. Now again using the same formula. So what do we have is the value of alpha. It's in a 2D frame. The value of alpha would be 3. Then value number of members are, we have to count the number of members here. This is 1, this is 2, this is 3, this is 4, this is 5, This is 6. So in total you have 6 members. R is the number of reactions. This is 1, this is 2, this is 3, this is 4, and this is 5. So total you have 5 reactions. Beta is the number of equilibrium equations. There are 3 for a frame. J is the number of joints. 1, 2, 3, 4, 5, 6, 7. 7 joints. Gamma 0. So now the value of SI would be 3 into number of members. Members are 6. Reactions are 1, 2, 3, 4, 5. Beta is 3. J value is 7. Gamma is 0. So overall it becomes 23 minus 21. It's 2. So the static indeterminacy here is 2. Now if for the same question I take the same question and I introduce any hinge here. This is an internal hinge here. This one, for example, this is internal hinge. हाँ जी, hello. Then what do you have? You have static indeterminacy is again this. Everything is same except that gamma value. Now the gamma value will not be 0. Gamma value will be
2.
number of elements connecting are 3 minus 1, so it's 2. Gamma now is 2. So that's what changed. So static indeterminacy ka value, it would be 3 into 6. So this here would be 2. This is 2 here. So total it becomes not 2, it becomes 4. So next we move to the second topic is kinematic indeterminacy. Static indeterminacy occurs under static loading conditions. And static indeterminacy basically means when you are analyzing the structure for the structure being statically determinate or indeterminate, meaning that the structure is not moving. It does not have any, you are not analyzing the degrees of freedom. But in kinematic analysis, what you are actually doing is that we are actually determining the number of degrees of freedom available at all the joints. But this is actually effective number of degrees of freedom. It includes both internal degrees of freedom, and it also includes external degrees of freedom. Now, for example, if you have a frame, in a frame, now this is a support here, this is a support here. What about these? These are joints. Now these joints could be, they are mostly in a frame, they are rigid joints. These joints here are rigid joints. Now what is the property of a rigid joint? What is the property of a rigid joint? It has got degrees of freedom in three directions. One is in vertical, second is horizontal, third one is rotation. That's the property of a 2D rigid joint. So it has got 3 degrees of freedom. That would be like this. One you have like this, second one you have like this, and the third one is the rotation that's occurring. The rotation. So it's actually able to move in all these 3 directions. When we are saying that it's able to move, so it has in 2D, for a 2D rigid joint, each joint has got 3 degrees of freedom. Now for a 3D rigid joint, if it's a 3D rigid joint, it will have 6 degrees of freedom. They will be, just a minute. In a 3D rigid joint, you will have 1, 2, then you have rotation. This would be same for 2D, but now you have additional third translation. Then you have additional rotations in along 3 different planes. So overall, you have mxy, myz, mzx, not moments, rotations. You can say theta xy, theta yz, theta zx. Then you have rotation translations, which are, so for example, you say delta x, delta y, and delta z. So these are the 6 degrees of freedom for a 3D rigid joint. So overall, what do we have now is this. Now the kinematic indeterminacy would be S into J minus T plus gamma. This is the formula for determining the kinematic indeterminacy. Now what is S here? S is the number of degrees of freedom available at each joint. J is the number of joints D is number of restraints or reactions. Gamma is number of releases. What is S? It's the number of degrees of freedom available at each joint. For every joint, you will have certain number of degrees of freedom available. So when you multiply that with J, the number of joints, you get the total number of degrees of freedom. But there are certain restraints, which is T, or reactions, which are available at the supports. Once you subtract that, you get the overall picture of the number of degrees of freedom. So overall degrees of freedom is actually the degree of freedom available at all joints minus the restraint at the supports. The number of releases which occur at internal joints, they all also are degrees of freedom. Static indeterminacy में आप उनको subtract करते हो, यहाँ पर आप you are actually adding that because you are here determining the degree of freedom. So, for example, if we take a question, let me take a question here. If this is a beam, it's fixed at both ends, fixed here, at these two ends. Let there be a hinge here or a roller here. You have a roller here. So now, what is kinematic indeterminacy of this beam? As per this formula that we have just written down, it is, what is the value of S? S is the number of degrees of
degrees of
freedom.
freedom at each.
Number of degrees of freedom at each joint कितने हैं? 2 या 3? हर maximum number of degrees of freedom कितने हैं at every? Maximum number of degrees of freedom are
दो
3. 3. You will have, अगर आप fixed को खोल दोगे तो you will get actually 3 degrees. Maximum is 3. J is number of joints. Joints are 3 here. Then it's minus T. What is T? It's the restraints. The number of restraints. Now, how many restraints are there here? कितने restraints है? यहाँ पर 1, 2,
and
4, 5,